And I'm here with Jordan. We're going to present on the circuit part of the lab assignment that we had. And we're going to be using the truth table and the formulas to create the circuit and complete it. So we have the simplified version of the circuits already completed. We are going to bypass that part of how to get there. The alarm was given, but the fan we had to do on our own. So we're going to use these simplified formulas to create the circuit. And the first thing that we're going to do is we're going to start with the fan and make those connections. So we have two ands in this equation, so we're going to need two and gates for this part. We also are going to only have two inputs for each, so we need to make sure we change those as well. And then once we're finished with those two, we're going to have an OR statement here, so we need to bring in the OR gate and connect that to the end. And these are the OR gate's only going to take two inputs as well. We'll have these two connected. So now we have, for one of the AND gates, the first one, we have a cord and the temperature has to be connected. So we just take the cord and bring that down. And we're going to take the temperature as well. We're going to add that gate, or that input to that AND gate right there. The second one, we're going to have the temperature and V naught. So we're going to need an inverter for the voltage. We're going to connect that to that AND gate, to the voltage. And then we're going to take the temperature, which is normal, so we can just come and bring it in from that line right there. And that creates the circuit for the fan. Now for the alarm, we're going to have a C naught, and then we're going to have the voltage. So we're going to have to bring in a C naught, or an inverter for the alarm. And these are going to be ANDed as well. So we're going to need one more AND for this table, this circuit, which only is going to have two inputs on it. And then it's going to connect up to the alarm right there. So the cord is inverted there. And then we're to be taking the voltage straight. So we don't want to bring in the inverter part. We just want the voltage on its own. And that's going to be able to create our circuit for the alarm. When you go through the testing and use the inputs, so let's just say the low voltage for the alarm, you click that one and the alarm turns to 1. Now temperature doesn't really necessarily be involved with that one, but if you do turn on temperature, the alarm still stays at 1. And then also, if the temperature is on by itself, the fan should be on, which is correct there. And also when the temperature in the cord is on, the fan is still 1. And then when all three of them are on, the fan is still 1. And then Jordan's going to talk a little bit more about some simplification with the formula as well.
Yeah, so one thing I found super useful when I was building this was we watched that video on the ROM gates, and I don't know if you guys went over that or remember it, but 1 second here. Okay. So all the ROM gate is you tell it how many inputs and outputs you have, and it allows you to essentially do everything you're doing with your gates, but just with a simple your simple inputs and outputs here. So for your ROM gate, you put that in there. We've got 3. The address bit width is 3, and the data bit width is 2. And then you've got to put a splitter on both ends. Let's see, we got to face it west, and we only want to do 3 on both of these. Okay, so now we got 0, 1, and 2. So the way this works is our temperature is 0, our voltage is 1, right? So if you look at your, can't really see it over here. On your truth table, the temperature is in the 0 slot, so the one to the right, and then the low voltage is in the 1 slot, and then the cord is in the 2 slot. So to make that easier to see, I'll just flip this over. Instead of right-handed, we'll make it a left-handed splitter. And we'll just bring these down and line them up. So 2 is going to be the cord. Low voltage is going to be 1. Our temperature is going to be 0. I guess I didn't need to flip that over. Then we'll put a splitter on the other end, and same deal. We've got 2 outputs, our alarm and our fan. So we add those 2. And then I'm going to add 2 outputs just so that we can compare. And this one I do want to change. So we'll label these. Okay, so now we've got a way to test and see if this is right. But to do that, we've actually got to set up what each of these blocks mean. So to do that, we've got to go to, what is this mode called? Change values, that little hand at the top, and we can select each of these. And by selecting, we can tell them what they are. So the way this works is on my inputs, you got your 0, 1, and 2. So if I turn on temperature over here, we're now on the 1 spot, right? 0's in the left, and then as soon as I turn on temperature, which is in slot 0, we now go to the 1 slot. And it keeps going down the line. So if I do voltage, now we're 2 in binary, so that puts us in 2, and it just keeps going. So looking at the outputs on your truth table, the first one is 0 because alarm is 0 and fan is 0. The second one would be 1 because there's a 1 in the fan slot and a 0 in the alarm. The one under that would be a 2 because that's a binary 2, 1, 0. Under that, the next one is also going to be a 2. Then we're going to have a 0 on slot 4. So 0, 1, 2, 3, 4, 0. And then we're going to have a 1 in slot 5 and a 1 in slot 7. So to test this, we can now go through our circuit and test. Okay, our output is, no, let's see, our input is 1, temperature's on, low voltage is off, cord is off, and our output is that the fan is on. If we turn it on to low voltage, that kicks on our alarm on both of them. And then if we go to 3, that means our alarm's on and our fan is off. And then 4 means it's a 0, so nothing's happening. 5 kicks on your fan because that means you got your cord and your temperature on, or your temperature's high probably. And then we go to 6, shows that we've got 0, so nothing happens on our outputs. And then 7, got the cord, low voltage, and temp, and then outputs fan on both of them. I just found this super useful when I was building my circuit because it allowed me to troubleshoot it without jumping back and forth too often. So I think that's all we've got for our presentation. Thanks for watching.